Okay, good morning. Welcome to
SuperMath number 72.
SuperMath number 72. So we did a little review on angle bisectors today. The next section is about constructing angle bisectors, but we're still in the challenging problem section. And we found a challenging problem about angle bisectors. So angle bisectors have three important properties. One is that when I chop an angle in half, when I bisect it, this line segment here is equally distant from both sides. Okay? Now why is that?
Well, because these angles are the same.
Okay. So what happens? How do we show that this distance, this perpendicular distance here and this perpendicular distance are the same?
Well, we can show that these triangles are congruent.
Okay.
So we have angle side.
Right. Angle side congruency. They share that side. They have right angle. They have this angle. That means this third angle here must be the same because why?
Because you have two angles and the third is forced.
Third is forced because
That's how triangles work.
because
Angles in a triangle sum up to be 180.
angles in a triangle sum up to be 180. Okay? So the angle bisector is equally distant from the two opposite sides. The intersection of the angle bisectors, let's draw it there, is the center of the inscribed circle of the triangle. And it's because from this point's equally distant from all three sides, so you can draw a circle that just touches at those points. The important thing is it doesn't touch necessarily at the foot of the angle bisectors. Like you can see here, for example, this point where it touches is not the same as that angle bisector. Okay? But it does touch. I think I accidentally drew it the same there. And then we have something called the angle bisector theorem, which is a really important theorem for finding lengths of sides in a triangle. And it says if I have a triangle like this, A, B, C, and then I have the angle bisector here coming down, and it hits a D, then I know AB to AC is what?
AB to AC is CD to BD.
Okay, now why is that?
I think BD.
BD, okay. Sorry.
Well,
Why is AB to AC, CD to BD?
no, it's BD to CD.
It's BD to CD, okay. Why is it BD to CD?
Well, you have you have two triangles which are on the same base.
Column triangles 1 and 2, okay.
They're on the same base, CD.
Yeah,
And they have the same height.
okay. So I know the ratio of these triangles. The area of this triangle is 1/2 BD times height. The area of this triangle is 1/2 CD times height. Since the height is the same, I get a ratio of their areas from area 1 to area 2 is BD to CD. Okay?
And
How do I
then,
get the AB to AC?
so you can look at them differently. So you can also say they have the base AC and this height coming out from D.
Okay.
And the heights are the same because this is an angle bisector.
Because this is an angle bisector, that height and that height are the same.
So when you look at the ratios of the areas, the heights cancel, and you're left with AC, well, AB to AC.
AB. The area of triangle 1 is 1/2 AB times height. The area of triangle 2 is 1/2 AC times height. When you look at the ratios, those cancel, leaving AB over AC. So AB to AC, this to this, has to equal BD to CD. BD to CD. Okay?
Yeah.
So there we go. So there's three very important things about angle bisectors. And all three of these things come into play in important ways when we're looking at triangles. So glad we had a chance to review that today, and hopefully that helps understand angle bisectors.